So I just want to say good evening to everybody once again, and welcome to our review of the January 28th and 29th blizzard of 2022. You just have me tonight. I'm Joe Deli Carpini, the Science and Operations Officer, and I'm going to take you through a pretty thorough look at the storm from a forecasting standpoint and analysis standpoint, and show you some of the things that we came up with about this particular storm. It was a pretty impressive storm for our area. So just to get started, I'm sure we all have a lot of snowfall pictures. This was the scene outside of our office in Norton, kind of during the height of the storm. You can see some pretty good snow drifts out here in front of the building, fairly common across the whole area and in our front parking lot. This certainly was a difficult storm to measure, I think, for many of you. We heard that quite a bit. Strong winds across much of the area, aside from out in western Massachusetts and Connecticut where less snow fell. But over Rhode Island, central eastern Massachusetts, certainly some drifts upwards of 3 and even 4 feet in spots. So this is a look kind of on a large scale at what the storm brought to the Northeast. And you can see pretty impressive snow totals from the mid-Atlantic states all the way up through Long Island. Here in southern New England was kind of the jackpot, also into portions of New Hampshire and Maine especially. So you can see the highest totals pretty much hugging right along the coast and a pretty sharp gradient. Meaning you're going from, almost a foot of snow to nearly just a few inches or even less than an inch as you get across portions of northern New England, western Massachusetts, and the lower Hudson Valley into the Poconos in Pennsylvania. So certainly a pretty impressive storm and definitely affected some of the higher population centers from D.C. up through Boston and Portland. Zooming in a little bit closer to home, you can see some of the observed snowfall here, and these are all courtesy of your reports, which we always appreciate. Some totals here on the left at the office in Norton, just over 29 inches. Boston Logan, almost 2 feet, 23.6. TF Green near Providence, 18.8. Worcester Airport, 14.7. And Bradley out in Windsor Locks, the Hartford area, 6.8 inches. And you can see definitely a sharp gradient here. Less than 6 inches of snow out in western Massachusetts with a couple of exceptions. Once you go over the border into New York, just about 2 inches of snow fell. So a pretty tight gradient. And again, the highest amounts focused across eastern Connecticut, Rhode Island, central and eastern Massachusetts, with kind of the jackpot was in Stoughton. That was the highest report that we received, just over 30, almost 31 inches. So pretty impressive. And much of the South Shore here, these communities were about 2 feet of snow. And you can see even on the Cape and the islands did pretty well. We didn't have any reports from Nantucket, unfortunately, but for the most part, about 8 to 12 inches for the Cape and the islands. So let's talk about some records, and there certainly were some from this storm. First, for Boston, the 23.6 inch total broke a few records. First of all, it tied the all-time record daily snowfall. That was the same amount reported in the blizzard of 2003, February 17th. It broke the daily snowfall record for the month of January, which was 22.1 inches on January 27th of 2015. Also broke the daily snowfall record for January 29th, which was kind of a measly 3.7 inches back in 1928. Those are kind of the easiest records to break. And then when we look at storm totals, we pretty much look at a 2-day total. So these 2-day totals here, we had a second highest 2-day total, and that was the just over 23.6. There was a little bit more that fell after midnight, but that was behind 24.4 on January 26th and 27th of 2015. And overall, it was the 6th highest storm total as far as snowstorms, the highest being 27.6. Again, the blizzard of 2003 just edged out the blizzard of 78, which was right behind that. Now, also, Providence and Worcester broke some records too, so we'll show them here. Providence, you can see the all-time highest daily snowfall that passed February 4th of 1961. Highest daily snowfall for January, which was January 23rd of 2005. And the daily snowfall for January 28th, which was back in 1912. This was also the 3rd highest storm total, or 2-day total, and was just falls beneath the blizzard of 78, which was quite a bit higher, 28.6 inches, and was also the 2nd highest storm total for the month of January, that being 23.4. That was the blizzard of 2005, January 22nd and 23. And not to be outdone for Worcester, record daily snowfall for January 28th. That surpassed the record of 11.5 inches set in 1973. And it was also the 6th highest January daily snowfall. The highest was The blizzard of 2015, 31.9 inches, so not bad. And Hartford, obviously, with a lower snowfall total, no records were broken there. So the storm also featured a pretty strong wind gusts across much of the area. We tried to map it out, but showing wind gusts of about 40 miles per hour or greater. That's why there's kind of a data drop off here on the fringes. But you can see widespread 40 to 50 mile per hour gusts across much of the interior. Even at TF Green Airport, 66 miles per hour. And certainly the highest gusts were focused along the coast, which we typically see. On Cape Cod in particular, gusts as high as 73 miles per hour, nearly hurricane force. Block Island Jetty was 72 miles per hour. So widespread wind gusts, and you can see some of them listed here, even 81 miles per hour in West Dennis, 76 up in Rockport on Cape Ann, offshore of Chatham, 78 miles per hour, 75 at Point Judith. So pretty strong wind gusts, pretty impressive system as well. And we'll talk a little bit about the wind from this storm. Power outages, there certainly were a lot. We have data from Massachusetts. This was kind of during the height of the storm, and you can see most of them focused right along the immediate coast. This is where we had initially some heavy wet snow, kind of a wetter consistency as opposed to other areas where it was more dry and powdery, and also combined with the strongest wind. So no surprise, Cape Cod kind of bore the brunt of the power outages, over 116,000 across the Commonwealth during the height of the storm. So let's talk about blizzard and what defines a blizzard. First, there are really three things. First, falling or blowing snow, reducing visibility to less than 1/4 mile. You also need winds frequently gusting to 35 miles per hour or more, and both of these must be dominant conditions for at least 3 consecutive hours. So, and going back to our airport weather observations, which are kind of the standard for looking at this, we were able to verify blizzard at several locations, including Boston, Worcester, Beverly, Hyannis, Marshfield, and Martha's Vineyard, and in Rhode Island, Providence, Westerly, Newport, and Block Island. Some of the stations had some missing data, either due to power outages or equipment failures, so that would include Chatham, Falmouth, Provincetown, and Smithfield, but pretty much those areas hit blizzard conditions as well. Some came pretty close in areas just outside of Boston, Bedford, Norwood. Didn't quite hit the wind criteria. Winds were more like 30 miles per hour, so it came just short, but pretty much a sizable snowstorm and blizzard for much of Rhode Island, central and eastern Massachusetts. Okay, so let's get into some of the forecast challenges here from the storm. And if you remember, the uncertainty was very high given the different variety of model solutions. Even within 24 hours, we were still seeing two camps, and I'll show that a little bit, with the GFS kind of being the most offshore and the other models being closer and showing a big hit. One of the concerns was what's called offshore convection or offshore thunderstorms. We see that a lot of times with these systems coming out of the Gulf, which this was one of them. Off the southeast coast of the U.S., you often see showers and thunderstorms develop, and sometimes that can either rob moisture from the storm, or it can also lead to a weaker coastal system. It kind of robs some of the energy, and the system's more what we call strung out, weaker series of lows as opposed to one definitive strong low pressure system. So we were kind of seeing that in some of the model data, and that was definitely a concern. The winners for this one, and not always the case, but at least in this storm, the European model, the UK Met, and the NAM were initially more correct in showing more of a closer pass and a greater impact to New England. The GFS did come on board closer to the storm itself. So what we had to do, and we in this situation with so much uncertainty, kept our messaging more probabilistic. You probably noticed that, and I'll show some examples here toward the end. But even within 24 hours of the storm, with all the uncertainty, we really couldn't lock into one camp at that point because the stakes were so high. If you go with the European solution, which ended up being correct on the UK Met, advertising a blizzard with 1 to 2 feet of snow plus, and then what happens if the system didn't pan out and moved offshore? That's a huge bust, and a lot of money is spent by our emergency management in towns and cities for really nothing. So we had to be careful in couching our message a little bit, and really the focus should be on storm ingredients, not some of what we call this post-processed output, like snow, the snow maps or things like that. So you need to be careful. And again, our models, weather models 202, we'll get into that a little bit more. So starting on the kind of the bigger picture, looking at some of the Ensemble solutions a couple of days ahead of time, we knew there was the potential here for a highly unusual event. On the left here, this is called our situational awareness table, and I'll use this in the briefing tonight as well. It shows, when all these things are lining up and you see a lot of mins or higher percentiles, these are called, in this area, something big is kind of going on in the region. This is for the Northeast. So, obviously there was going to be a strong coastal low. The question would just be, where's it going to be? And a lot of these parameters focus on things like temperature and wind speed and moisture, and they're all kind of coming together here for the Saturday into early Sunday time period. And then on the right, this is a look at the Ensemble low-level wind field. This is about 925 millibars, or about 2,500 feet. And you can see the circled area, that purple shading, showing the winds out of the Northeast were forecast to be 3 to 4 standard deviations above what is normal or above climatology. So that signals to us that the greater these departures, the more likely you're going to get some sort of unusual event. And when we look at the low-level winds, that tends to be coming in the form of moisture and wind speed. So you're looking at two things: the high wind potential and the potential for some excessive rainfall or heavy snows in this case. So just a quick reminder here on our storm tracks that we typically look at, and you've probably heard we talk about the benchmark, and that's that 40 degrees north, 70 degrees west, this crosshair here. So when we have a storm that's offshore, outside the benchmark, east of the benchmark, that tends to focus the heavier snow somewhere south coast, Cape and Islands, sometimes into Providence, up to Plymouth, that area, with lighter snows farther to the northwest. But pretty much it's an all snow situation. So this is certainly one of the possibilities we were looking at in the days leading up to the storm. And the other was a benchmark storm, which is right over that 40-70 crosshair. That favors really the I-95 corridor, anywhere, even up into Hartford in some cases, but especially Providence to Boston. These are the ones that usually end up in the jackpot for that corridor. Sometimes you can end up with rain getting onto the south coast, Cape and Islands, if we can get the warmer air in. But if it's cold enough, it ends up being some lighter snows, and certainly lighter snows farther to the northwest, up into central New England. So it was really a battle between these two tracks. So is it going to be more over the benchmark or just outside, which favors Providence to Boston and down kind of in toward New London, or was it going to be more offshore, favoring kind of the Cape and Islands? And a lot of the model forecasts kind of wobbled between those two solutions in the days leading up to the storm. So one of the things we can look at is the Ensemble guidance and looking at the various low locations for each of the members. So if you remember, an ensemble is taking a look at different runs of a specific model, kind of tweaking things at the start. So you're changing some of the initial conditions to get different results. And this is the result of one of the things we look at is where are the low positions. So you can kind of see the contours are showing us a mean position somewhere, a little bit southeast of the benchmark. Benchmark will be up in here. But you can see there is some clustering in the solution. This was on Thursday, and this kind of was getting our attention a little bit. But the European at that point had been pretty consistent. It was going to be a big hit. But that solution was kind of on the western side of what we call this envelope. So you had a cluster of lows here, closer to the coast. You've got a bunch that are probably just a little bit east of the benchmark, showing more favorable for the Cape and the Islands. But look, you've also got a third cluster way out here, which would be a miss. So, do you go with the one closer to the coast, which could end up actually being some rain on the Cape and the Islands and possibly into Providence and Boston? Do you go with one closer to the benchmark, which is a big hit for us? Or do you go out here? And it's really, you're kind of looking probabilistic at that point. And this was, a couple of days before. We're not looking 4 and 5 days away. So you look at, we look at the European model. We look at the Canadian model and its ensemble members. We look at the GFS and its ensemble members. The GFS was certainly more offshore. The Canadian was somewhere in between. But eventually we did note the trending more toward the European solution. But it's a tough call. I'll be honest with you. We don't always know. And it's, based on a little intuition, a little experience, and sometimes, yes, even a little bit of guessing as to which one is going to be right. So just to show you, I want to show you some of the trends on this. And this is a great animation we came up with. This is looking at the 500 millibar height. So you're about 18,000 feet, or the steering level that we look at for storms. And notice this is the trough that was going to lift the system up from the Gulf. You can see all this southerly flow up the East Coast. And notice as it starts off, it's going to loop from 48 hours to about 24 hours ahead of the storm. So the first forecast is 48. Notice the trough with time sharpens a little bit. It gets a little bit sharper to the point where the flow here along the eastern seaboard kind of what we call backs or becomes more southerly. Initially, it's more southwest to northeast, which would carry the storm offshore, but eventually it tightens up a little bit and goes a little bit more southerly, which would draw the storm closer to us here in southern New England and make more of an impact. So it's building that sharper trough, which is what we want to see, bringing the storm closer to the coast. But it's funny because after this run on, I believe it was the 28th, early in the morning, all models shifted east. So then we're like, okay, now what? Now we're in about 12, 24 hours of the storm. So it's not always this easy, but certainly the trends are always good to look at on model runs, and that's something that really played into us gaining more confidence that it was going to be a bigger storm. So certainly looking at the other models too. This is the Canadian model, looking at a 48-hour forecast, and it's tough to tell, but it's actually showing a pretty big hit. It's got the low just outside the benchmark, but a pretty good swath of snow from Long Island up into southeast New England. The UK Met not shown here, but our rule of thumb, and it really still works, when the European and the UK Met show a big hit for us, it usually tends to happen. And for those of you who remember Walt Drag from back in the day, that was one of his rules. And boy, I'll tell you, it still works. So remember those two, European and the UK Met, if they show something big, the chances are, the odds favor something's going to happen. So now let's focus in a little bit. This is the NAM, and this is looking at a 55 hours. So we're out a couple of days from the storm, but note this band of what we call frontogenesis. This is looking up at about 10,000 feet, 700 millibars. This is a pretty solid band, and what this is, it's just an area of temperature difference. So think about it as like a warm front aloft, so a warm front up at about 10,000 feet. We call the area of lift from that frontogenesis, and it's focused over southeast New England. Note the axis is pretty much over the Cape Cod Canal. Now, the thing to remember is the maximum snowfall doesn't occur right along this band. It actually occurs just to the northwest of this feature. And where would that be? Well, it would be right in Rhode Island and kind of southeast Massachusetts, up close to Boston too, and eastern Connecticut. So kind of these areas right here, if the simulation were correct, and actually it did a pretty good job, those are the areas of hitting the jackpot. So if you're looking up aloft, this is one thing with winter storms you want to look at. Where is that? We call this the mid-level band of heavy snow. Sometimes it can be farther inland, but with a more offshore track like this took, it was a little bit closer to the coastal areas. Now, a little closer in time, this is about a day and a half out, 30-hour forecast. Note the axis has shifted a little bit farther inland, and actually this was a little bit too far inland. I think the earlier forecast was more correct. But something else I want you to key on is the wind field. So we've got our band of frontogenesis. Again, this is our temperature contrast. But note the winds. So you've got, over the interior areas, you've got pretty strong northeast winds. And to the south, we've got these what we call screaming southerly winds. These are bringing in a lot of moisture from the south too. And where they converge is right over this area of frontogenesis. So what we call this is known as kind of a back-bent warm front, or kind of a warm front that extends in this direction as opposed to like a west to east. So it's actually the warmer and more moist air is kind of surging in from the ocean. It's coming into this cold dome that's in place. And what's going to happen, it's going to condense, it's going to converge, which means you're getting more lift. So you're getting lift, moisture, and that's going to dump a good band of heavy snow. So again, that's something else you want to focus on at about this 700 millibar level is frontogenesis, and look at the wind convergence as well. If you go back to many of our big winter storms, you'll see this feature is pretty prevalent in all of them. It's just a location that we need to determine to find out where the heavy snow is going to be. Okay, so if we drill down a little bit more, let's look at a forecast sounding. This is over New Bedford, and this is from the NAM. And it's a couple of days out, but it's always interesting to look at. So this is, again, near New Bedford in southeast Massachusetts. And you can see it's in the corridor of the heaviest snow that the model was spitting out at that point. So the things you want to note, first of all, the green is the dew point, the red is the temperature, and this is going up with height. So notice how the lines are right close to one another. That means the air mass is saturated. There's high relative humidity. And obviously we want to have that for snow to fall. It's also all below freezing. So if you look at these dashed lines that kind of run from the lower corner up to here, these are the temperatures in Celsius. So the freezing line's way out here. This sounding is well below freezing. There's no question it's going to be snow. There's no issues with sleet, freezing rain, or even rain. So this is an all snow sounding. And then on the left, notice we've got these kind of bars here. This is what's called lift, or we've also termed it's called omega, but it's essentially where your lift is occurring. And note, it's occurring in that layer. This is 500 to 700 millibars, which is roughly 10 to 18,000 feet. But notice it's also between these two bars called DGZ. That's the dendritic growth zone. What is that? Well, that's the temperatures where you're going to get the maximum snowflake production, those big silver dollar size snowflakes that pile up really quick. So that's what you want to see, the big dendrites. And whenever you have the max lift centered in this dendritic growth zone, which is shown here, you're going to really pile up snow very fast, easily seeing snowfall rates 1 to 2 or maybe even 3 inches per hour. So this is probably the most classic sounding you're going to see for heavy snow. Below freezing, it's saturated, and your maximum lift is centered within this dendritic growth zone. So very supportive of heavy snow. So the other issue were wind gusts, and how do we assess that? We also look at the soundings, and these were from the NAM, looking a couple days ahead of time for 3 different locations. We have Boston here on the left, Plymouth in the middle, Nantucket on the right. So this is looking at the mixing depth. So the mixing depth on the sounding, again, is shown here on the right. This is your temperature curve, but notice where it's gray. This is showing the amount of mixing that can occur. So anywhere in this layer, you can mix down the winds. Now, the average speed is shown by the lower number, 38 knots or about 44 miles per hour, 46 knots and 46 knots at Nantucket. The upper number is kind of the max in this layer, that if everything comes right to perfectly, that's what you'll see. So potential for a 50 knot or close to 60 mile per hour wind in Boston. Plymouth, 60 knots, close to 70 miles per hour, and Nantucket, 51 knots, or also close to 60 miles per hour. So it pretty much was a lock for winds of anywhere between 40 and 50 miles per hour on this lower range, or even 55 miles per hour, with the potential for winds of about 60 to 70 miles per hour. And what did we see? We saw over 70 miles per hour. So things did come together right. So when we're looking at winds this strong, combined with the low visibility from heavy snow, that's when we start to think, okay, we got to bring out the B word, which is blizzard, which really gets the excitement going and certainly gets the attention of everybody. So I want to show some of the runs from our high resolution ensemble, and this is used within about 36 to 48 hours. If you've been with us before, you've seen us use the HREF. This is an ensemble of several high resolution models. Think of models that can simulate down to thunderstorm scale or almost the neighborhood scale. So these are very, very useful for things like snow bands in the wintertime or thunderstorms or sea breezes, very localized features. So this is looking at a map of the chance of seeing 12 inches of snow or more in a 24-hour period. I've zoomed it in on the left so you can see it a little bit better, but look at these high probabilities. 80 to 90% here, Plymouth County to Cape Cod, even up into close the North Shore of Boston here, Gloucester, and even 70% or greater across much of Metro Boston, the South Shore, into Providence, and points eastward. But pretty good drop off as you get from Worcester County on westward, and almost nothing out toward the Berkshires and Litchfield County. So this was telling us, this was going to be a pretty big hit for the coast, and maybe not so much inland, maybe into Worcester County. It's kind of 30-40% there. But this certainly is signaling a big hit along coastal areas, Long Island, Cape Cod, up into down East Maine. And then if we look at the actual mean snowfall from the entire ensemble, this is taking snowfall forecasts from each of them and kind of blending it into a mean or an average. Again, zooming up here on the left, you can see it's got totals there of 27 to 30 inches, even a pocket of 30 to 33 in Plymouth County, which turned out to be pretty good. It was just off a little bit in location. But definitely the potential for over a foot of snow where you see yellow on eastward from Worcester County on east into northeast Connecticut, northern Rhode Island. But certainly, again, the highest corridor, Long Island, Cape Cod, up into down East Maine. So a very good job. And you can see it drops off pretty well as you go to the west. Western Massachusetts, you're looking 1 to 2, 2 to 4, 4 to 6 in spots at most. So really did a nice job here. And this was a forecast of roughly, almost 36 hours. Pretty good. So then the other thing it does some nice what we call post-process guidance, looking at different fields. This is the chance of blizzard conditions. So note over the land, and you can see in the zoomed up area, the probabilities were actually pretty low, but over the water, they seem to be much higher. And this is kind of a known bias or known weakness of the ensemble. The winds over the land are typically not as strong as what it does over the water. It has to do with the mixing that I showed in the soundings for each of the high resolution models. So what I would do is kind of eyeball this. So this is high here over the Gulf of Maine and Mass Bay. You can eyeball this and kind of extend this down into the water. So Rhode Island, Eastern Massachusetts are going to have higher probabilities here than what's shown by the model. So that's kind of the change that we made, kind of in the back of our minds in the office, knowing, okay, it's not showing a lot, but this area is pretty much under the highest threat anywhere in eastern Connecticut, Worcester County on east for blizzard conditions. And again, HRF did a very nice job in highlighting that potential. So I wanted to show one little more model data here, just what we call the national blend of models. And what this is think of it as the kitchen sink. Every model we have available, whether it's from United States, Europe, anywhere, some of the statistical guidance, like we call the Moss guidance, every piece of guidance we have is thrown into this blend. And this is the snowfall forecast from several different runs. So we're looking at the runs the day before and leading up to the storm here on the top. Notice the snowfall totals are increasing in the models as we get closer. They're incorporating more of the high resolution models, which have more skill. And again, pegging Southeast Massachusetts, pretty good job, and showing that gradient across the interior. And then here's the bias on the bottom. So this is the difference as to what fell versus what it forecast. And you can see overall, kind of an under forecast initially the day before here, as much as, it looks like, over 6 inches, 8 to 10, some spots, even the day of, and then finally it overdid it a little bit. But you can see, overall not bad area-wise, just the amounts are off a little bit. So this is sometimes the starting point for the forecast that we use, especially for the extended forecast. So when you start to see snow totals out in like a 48 or even 2 to 3 days out, we're pretty much leaning on the national blend. It's a pretty good middle of the ground approach as far as putting forecasts out beyond 2 days. So just want to show that, initially it is too low, and this is a known bias. And then as you get into the event, it actually can be a little bit too high. So we apply that kind of correction in our forecast. So just to remind you what goes into a snowfall forecast, and we'll talk about this in the Weather Models 202, a lot of things, a lot of moving parts here, and lots of possible errors from each of them. Storm track and evolution that I just talked about, features at the surface, aloft. How much liquid precipitation are you going to have? What's the snow to liquid ratio? Is it going to be a wet cement-like snow or a dry powdery snow? What's the snowfall rate? What's the snowflake type? We talked about that, the dendritic growth zone. What's the surface temperature? Is it going to melt on contact, freeze on contact? Ground temperature is also important. That came into play with this past Sunday storm. It was warm over the weekend. Saturday, record highs. So you notice the snow didn't really stick to the roads right away. It took some time and much more. So my point is there are a lot of different things that go into the forecast. Any one of these, if you misdiagnose them, you're going to end up with kind of a poor snowfall forecast. So there's quite a bit that goes into it, and it's certainly not to make excuses. It's just to explain a little bit how we look at producing snowfall forecasts, and yeah, there's a lot. So let's take a look at some analysis of this storm. Now we looked at some of the forecast information, and really what we found was the track of the 500, 700 millibar lows, which I'll show, were favorable for significant snowfall. And again, this is looking at the big picture, always good to do at the start. And the key feature was indeed the location of that frontogenesis band. To a lesser extent, the temperature gradient a little bit lower at 850 or 925 millibars. So that's down anywhere from about 2,000 to 5,000 feet, as opposed to 10,000 feet where that frontogenesis band was. And certainly, the presence of Arctic air in the snow growth zone led to high what we call the SLRs, snow to liquid ratio, or the fluff factor. So I think many of you remember this was not too difficult to clean up, even though there was a good 2 feet of snow here in the east. It was very fluffy. So really the key takeaways are to assess the tracks of these upper lows to determine the location of heavy snow. Again, the 700 millibar frontogenesis snowfall max occurs just to the west or northwest of that band. Lower level forcing occurs to the west or northwest of the temperature gradient, which I'll show you. And the snow to liquid ratios, they're determined from temperatures in that snow growth zone, not at the surface. So it can be 32 degrees, 34 degrees. You can have a dry powdery snow if it's cold enough aloft. And conversely, it can be 15 or 20 degrees at the surface, but if it's even warmer, a little bit warmer aloft, you'd have less snowflake production. or warmer snowflake production, where you would have more of a heavier wet snow, believe it or not, even with colder temperatures. All right, so let's take a quick look here at some of the analysis data. This is 500 millibars, 18,000 feet, and here's the progression. We're going to show most of the maps during the afternoon on the 28th from 1 to 4 to 7 p.m. So you can see the low is here south of New England at 1 o'clock. It starts to come closer to Cape Cod. It's kind of centered pretty close at that point to the islands, and then kind of actually closes off and sits there a little bit over the outer Cape at 7 p.m. So favorable snow is heavy a little bit to the northwest of this feature, so that would be near the south coast here, Providence, maybe to Plymouth here, and then certainly more of eastern central Massachusetts and northern Rhode Island toward the evening. So again, assessing this low track is a good way to get started on where your potential for heavy snow is. And in a similar fashion, 700 millibars, not even looking at that frontogenesis I showed, but just the position of the low itself. Notice it takes a similar track, a little bit faster, but anywhere from the islands up into the Gulf of Maine. That would put your heaviest snow back across probably eastern Connecticut, central Massachusetts, up into coastal Maine as this feature lifts northward. So this kind of identifies the two heavy snow threat areas in there, and also back across southeast Massachusetts by looking at the frontogenesis. Here is that frontogenesis. This is the analysis. Pretty close to what the NAM showed, a little bit farther east though. Notice at 1 o'clock it's closer to Nantucket. By 4 o'clock it's coming closer to the canals, so not a bad forecast from that earlier NAM forecast I showed you. And then by 7 o'clock it's starting to retreat a little bit off to Cape Cod Bay. And again, the band occurs just to the west-northwest of this feature. Now coming a little bit lower, now we're coming down to 5,000 feet, about 850 millibars. Notice the low is farther offshore, pretty typical the way these are stacked in the vertical. This is east of Nantucket, making its way up into the Gulf of Maine. But notice where the blue and red contours, these are temperature. They're kind of tighter and closer together. This is showing you the temperature gradient. So our area here in Massachusetts, Rhode Island, Connecticut is pretty firmly entrenched in the Arctic air, but there's a pretty good temperature gradient or change of temperature going on just offshore of the islands, and this is what brought some heavy snow into those areas as the afternoon and the evening progressed. So a lower level feature as opposed to the higher level lift, which was ongoing across the I-95 corridor. And then going a little bit lower to 2,500 feet, 925 millibars. Notice you've got a pretty good temperature gradient offshore as well, maybe even a little bit more to the Cape Cod Canal here, which is showing the potential for heavy snow in those areas through the afternoon. And of course, looking at just the basic station plot, showing, again, the top number on these is temperature. We were well into the teens, even some single numbers by evening. Arctic air firmly entrenched, certainly no issues with the rain or snow line this time, which is helpful. And then taking a look at the progression of our surface low, notice there's actually a second low here, a weaker one, which wasn't the main storm. The main one was here to the north, but they did analyze a weaker one to the south. Notice the progression and in strength. It actually goes from about what we call 975 millibars, which is what we assess pressure in. East of Cape Cod by 1 p.m., it's down to 972. Still 972 in the Gulf of Maine at 4 p.m. and holding near that into the evening as well. So the pressure change actually went from 1,004 millibars January 28th to 969 millibars there on January 29th. So drops 35 millibar in 24 hours. That is a bomb cyclone, which the definition is 24 millibars at least in a 24-hour period. So this matches up with our January 4th, 2018 bomb cyclone as being a pretty significant coastal storm for our area. So the other aspect was coastal flooding. I'll touch on this just briefly. It was fairly impactful. Minor to moderate flooding occurred during the Saturday morning high tide. We knew that was the higher of the astronomical tides, but we thought that the surge would come more in the afternoon and the evening during the lower high tide. Well, it turns out Mother Nature threw us a curveball on that. The winds ramped up a bit faster, brought the seas up higher, brought the surge up a little bit higher for the Saturday morning high tide. And we saw the greatest impacts really along the entire stretch of coastline, especially Newburyport, Scituate, Nantucket, Vineyard Haven, and Edgartown. Minor flooding did occur on the subsequent high tide Saturday evening and Sunday morning. But by that time, the surge was less as winds had shifted to the northwest behind the storm, thankfully. So we only had to deal with the most significant flooding on that Saturday morning high tide cycle. And of importance for us this season is erosion. Very significant issue. I'm sure you've seen on the news, Plum Island, Newburyport in particular, even down into Sandwich. And we often have needed to bump up our impacts, thinking even if it's just minor flooding, if we've got pretty high seas offshore, we get the message out that the erosion is going to be a pretty significant issue. And I know there are many homes that are vulnerable and dock structures, things like that, to erosion. So again, that's one thing we've kind of ramped up our message over the past year or two because of that. So just to go through some of the coastal flooding, we'll start up here in Gloucester, just showing the tide at Boston, which was about 13 feet during that morning high tide. And what we use are these what are called matrices. They take the combination of the water level on the left and the offshore wave height on the right. That helps us incorporate the wave action or the additional impacts from wave action. So here in Rockport, you can see this is from coastal zone management, water getting into, close to some coastal homes. In this case, we had seas of 15 to 20 feet offshore combined with a 13-foot tide. That puts us in the moderate flooding category, which we believe we saw in portions of Cape Ann, including Gloucester. Heading down the coast to Boston Harbor, again, a 13-foot tide in Boston. Waves in the harbor, obviously not quite as high. They were more in the order of about 2 to 3 feet. So that gives us widespread minor flooding. You can see here Long Wharf. This is from WBUR. Pretty widespread, but minor inundation. And when I mean minor inundation, I mean less than a foot of water depth. So, but pretty extensive. This is, more than your typical nuisance type flooding for Boston. It doesn't usually get this far away from the harbor itself. So pretty impressive. Now going down Scituate, obviously we know that's one of our big areas, ocean exposed. So at Scituate, the gauge read a max of 12 feet, and offshore our wave heights were just over 20 feet. So where does that put us? Solidly in the minor, even to some low-end moderate flooding, and I believe that's pretty much what we observed in this case. A couple of pictures here on the left. This was the flooding occurred, but you can see water was definitely into this part of the neighborhood here in Scituate. A lot of rocks and debris, which is indicative of more than just minor flooding. So my guess is you had over a foot of inundation, maybe on the order of 1 to 2 feet of inundation. I know several of the coastal roads were impassable during high tide at that point. And you can see here in Hull also some pretty deep water there and fairly widespread flooding. Working down to Cape Cod Bay, this is down looking at Dennis. Actually reached close to moderate flood stage, being 14.3, just shy of the 14.5 threshold for moderate flooding. But in Cape Cod Bay itself, seas were close to 10 feet, and that puts us solidly in the moderate flood category for Sandwich and Dennis, which is more extensive flooding. And you can see here some photos of the harbor in Dennis, also from around Sandwich. This is fairly deep water, and even some damage here to some structures as well from the water moving through. So the boardwalk there. So certainly a significant flood event for Sandwich and Dennis on Cape Cod Bay. Now, how about the islands? We'll finish up with those. Nantucket Harbor actually reached moderate flood stage Saturday morning, nearly 6.7 feet from the gauge alone. And we know offshore, outside of the harbor, seas were on the order of about 6 to 8 feet. So on our chart, that puts us right in the solid moderate category. And lo and behold, these are areas down near the ferry docks, Easy Street, Oak Street, and Easton Street. This is over a foot of inundation, looking at probably 2 feet on Easy Street itself, and a solid 1 to 2 feet in other areas. These roads were deemed impassable by the photographers from, these are Mass Coastal Zone Management folks. And on Martha's Vineyard too, we use right now the Nantucket gauge. We can kind of use that as kind of a proxy for Martha's Vineyard. Again, into the moderate flooding with about a 6.5-foot tide combined with 5-foot seas outside of the harbor. And yeah, sure enough, Vineyard Haven, the Five Corners area, probably a higher end minor. This is probably something you can drive through, but getting close to not being able to. Beach Road and Vineyard Haven was impassable during high tide. Edgartown saw quite a bit of flooding. This is actually a good block or two from the harbor on Dock Street, and it was widespread inundation. This is over a foot of depth. Everything was closed down to the Chappie Ferry as well. And in Oak Bluffs, on the other side of the island, Seaview Avenue actually was closed. There was debris coming over from these waves getting over the seawall. So a fairly impactful event for Martha's Vineyard. So messaging the blizzard as we go on, this is the last part that we'll talk about. As I mentioned in the beginning, messaging was certainly a challenge. We had the multiple hazards of snow, wind, and coastal flooding. Also, a lot of interest on social media several days in advance. This was, shown by many of the models in one form or the other. So we began our formal emergency management briefings on Tuesday, about 4 days ahead, which is a little bit earlier than we normally do. Typically, it's 2 to 3 days, but in this case, there was enough interest, enough of a potential impact. We decided to get the ball rolling on that. But the key takeaway from this is when you're in uncertain situations like this, where there's, I mentioned that uncertainty almost 24 hours ahead of the storm, best to ramp up your forecast and messaging slowly rather than start out with a big forecast. So on, Tuesday or Wednesday, we knew the potential was there for a foot of snow or even a little bit more, but we kind of couched things a little bit more conservatively. Don't come out with the big numbers yet, because once you put those numbers out, you can't take them back. If we put out a forecast of 1 to 2 feet on Tuesday, well, yeah, it would have been a great forecast, but at that point, there's no way we could have taken it back if the storm trended more offshore and ended up being a 6 to 12-inch snowstorm. So we have to be careful. Plus, a lot of the emergency management partners, towns and cities, they take action based upon what we're telling them. So we don't want them to start putting out, spending costs on positioning equipment, things like that, until we really have more certainty. And mentioning blizzard, you'll notice we typically don't do that in the Weather Service until almost 24 to 36 hours before at most. Blizzard conditions are very difficult to forecast. They can be localized in some cases. This was a case where it was more widespread. But we put that word out there, and again, you can't take it back. So we need to be confident that we're going to see the wind, we're going to see the low visibility for at least 3 consecutive hours. That is not an easy thing to do, believe it or not. So we want to be careful in using that. So typically, we will start off, getting to that by saying near blizzard conditions. And we did that during the storm, if you've noticed. On, I believe it was Wednesday or Thursday, we started mentioning near blizzard conditions. And then we went right to the blizzard warnings by the day before. And just a reminder, the area forecast discussions, they can be a little technical, but really provide the forecaster's reasoning, including what can go wrong or what we're looking at. So that's a great resource for you to look at if you're not familiar with those. So as far as our messaging, this is what we did early on, just kind of what we know, some of the unanswered questions and what you can do now, showing the uncertainty in the storm track. And this is going to be the theme pretty much for every winter storm that we deal with. 3 to 5 days out, we're doing something like this, talking about uncertainty. As we get, even showing things like this, you've probably seen the graphic on the model forecast error. We, say it's still too early. You're going to see that a lot. That's just very typical. For us here on the East Coast, anything beyond 3 days is going to be very difficult to forecast, unless it's an unusually significant winter storm. Typically, the model scale is about 3 days out at most for our winter storms. And then when we start getting into 1 to 2 days before, that's when we start to nail down some of the details, like those heavy snow bands and things like that. But anything beyond 3 days, really need to take with a grain of salt. The average error, as it shows here, over 150 miles. So think about that. Cape Cod to New Haven. Think about the differences in the impacts from a storm because of that. Now, as we drew closer to the event, and this was the 27th, confidence was increasing. It should, on coastal storm impacts for parts of southern New England. So notice we still had uncertainty in the exact track, still some wobbles, but higher confidence in, where the heavy snow was going to be, where the strongest winds were going to be. And notice on, Thursday, we're saying near blizzard conditions. We're not saying full-fledged blizzard depth because of the uncertainty. So we're getting there. This is the way you'll notice we ramp up. That's how we get to our final kind of forecast. And kind of, if you read in between the lines, if we start saying near blizzard conditions a day or two out, obviously we're thinking about blizzard warnings at some point. And finally, just to wrap up our decision support briefings, we did quite a few video briefings, which is something new in our pandemic age here for Massachusetts and Rhode Island emergency management leading up to the blizzard. Those started on Tuesday, and you can see kind of our calendar there for the couple of days before the storm. These have been really successful. We can show them what we're thinking in addition to talking to them. We didn't have them for Connecticut this time just because Connecticut wasn't expected to be as impacted as much. They were in the eastern part of the state, but certainly Rhode Island and Massachusetts were more under the gun as far as impacts. Multiple phone briefings done in the days throughout the storms, especially Massachusetts. We had calls with the governor and the cabinet, also with cities and local towns, Mass DOT, Massport, quite a few calls throughout the day. Also, we had phone briefings with Rhode Island Emergency Management throughout the day, at least a couple of calls per day. In addition to all that are email briefings, at least twice per day for all three states, also federal, state, and local partners from FEMA down to the Coast Guard, the Steamship Authority. All of our partners there get the message one way or the other. And of course, on top of that, also all kinds of different phone calls going on. So just to show you a storm timeline of what happened, this is, again, fairly typical for just about every winter storm we deal with. So starting on the 24th, early in that week, we're kind of in our pre-storm mode, doing our forecasts. And I put a note there. This includes collaboration with the Weather Prediction Center, all of our neighboring offices. Think Gray, Maine, Albany, New York City. Sometimes even beyond that, we expand down to Philadelphia, Binghamton, Burlington, Vermont. Some of the other offices. All make sure we get on the same page with producing, a seamless snowfall forecast and discuss the impacts. As I mentioned, the emergency management briefings start then. Don't forget social media. We like to post a lot on there. That's a great way to get information out. Media briefings, phone briefings from newspapers and online media as well. Chats with the TV meteorologists we have online. And then staffing and office preparations too. We need to make sure we've got people ready who are available. Office preparations. What if we get stuck at the office? We got to make sure we have enough supplies and things like that. Make sure people can get in and get out. And then when we get to the, a couple of days before, we're in the watches and warnings. So we're starting to collaborate all of that in addition to doing all of the other information. And then the blizzard itself, forecasts continue. We're dealing with spotter reports, working on those, staying aware of what's happening. Still doing emergency management briefings. What's happening? Is anything changing? Is things going according to plan? And media briefings, same thing. How's the storm going? What's happening? Helping to get the word out. And then post-storm, this can be just as busy, believe it or not. We're still doing our routine forecasts. We're compiling all of the spotter reports. And for this storm, literally hundreds and hundreds of observations, which went into that snowfall map that you saw. Post-storm EM briefings for restoration, recovery efforts. Think about, power restoration, storm cleanup, where you've got 3 feet of snow. The towns need help sometimes. And media briefings continue. What happened? We want to document the storm as best we can for the media. So this is pretty much, again, the same timeline just about every storm I've worked in my career, but it starts, can start 5 to 7 days before and go 5 to 7 days later. And then what if you've got another storm the following week? Then it starts all over again. So, to me, this is the time that gets busiest. This and the tropical season are the busy ones, but certainly it is very enjoyable, and it's a lot of work, but it's also very rewarding too. So I just thought I would throw that in. So in summary, this was probably our biggest storm since the January 4th, 2018 blizzard. Greater than 2 feet of snow in parts of the area, high winds, much of the eastern third of our area, and coastal flooding as well. It did have high uncertainty in the track and impacts, even 24 to 36 hours before, which is fairly unusual. Normally we see good model agreement by then, but once in a while that happens. The forecast really focused on the storm ingredients. Again, that 700 millibar frontogenesis I showed was key, in addition to showing the where the lift was centered in that snow growth region for the eastern areas. And again, in situations like this, the messaging gradually ramps up through the uncertainty. So you're going to notice on our snow forecast, the first ones that come out 3 days before, they're going to be conservative. You might only see 3 to 6 inches. And then as we get closer, as we get more confidence, things will start to ramp up. So that's when you start to see the foot plus totals. And even in this case, we went to 2 feet, a day. We started talking to the emergency managers a couple of days ahead saying, hey, we're not confident, but some areas in south of Boston could see 2 feet of snow out of this. And it did pan out, but we're not overly confident all the time in those things. So you'll notice the messaging will ramp up with almost all storms as we get closer in time. So with that, that will do it for this part of our presentation. I'm going to pause here and I'm sure we've got a lot of questions, so let me kind of scroll through them myself here, and we'll answer a bunch, and then if you want to hang around, we'll get to a weather briefing talking about our late week mild system, and then kind of looking at the pattern here as we go into early March. So let's see, Fred, Newton had 23, not 12. Yeah, I think that was an older map, so it didn't have the latest totals on there. Newton definitely did have 23 inches. Thank you, Fred, for that clarification. From Samuel, why is it so difficult to forecast convective banding before the storm actually occurs? Great question. So this is what we call one of our mesoscale features. Think smaller scale, regional scale features. Our models, the models that can handle that the best are these high resolution models, and their strength is really anything within about 36 hours. They only run that far out for a reason, because once you get outside of 36 hours, 2 days, 3 days, so much error piles up, it's pretty much useless, believe it or not. So the larger models, your Europeans, GFS, Canadian, those are not designed to really detect these smaller scale features. They're good, and in some cases they'll give you a general idea, but it's these higher resolution models that really are designed to focus on this banding. And plus, sometimes, I will be honest, we don't know where the bands are going to end up until they're on radar. So it can be almost 6 hours before, as we're seeing bands of snow coming in off the ocean on radar, where are they going? How far inland are they going to get? Where are they going to pivot or sit? So very, very difficult. Almost like, think about it like forecasting thunderstorm location in the summertime. It's tough. It can be a popcorn type day where it pops up anywhere, or you can have an organized line. Even those are difficult. So this is something where modeling is focused on for the next 5 to 10 years, and I think we will see quite a bit of improvement, but it's going to take some time. So again, that's one of the most difficult aspects of the storm. Great question. So from Kevin, were the snow to liquid ratios in the 20-to-1 or higher? How did this play into the fluff factor and totals? Yeah, because of the Arctic air and where the lift was centered over us, a lot of the snowfall totals were in the 15 to 20-to-1 range. That's fluffy, fluffy snow. On average, a typical snow is like 10 or 12-to-1. Wet cement snow is going to be a 5 or 8-to-1. So some areas on the Cape and South Shore did see kind of that wetter consistency of the snow initially, about 5-to-1, 8-to-1. But then as that Arctic air really drops south, they also transitioned to a powdery snow, and that actually helped them out, preventing further power outages during that Saturday night time frame. So that really helped out there. All right, let's see. From Tom, compare and contrast the 2022 blizzard to the storm that preceded the 78 blizzard by 2 weeks. Oh, you're making me go back. So the one, we actually had a big winter storm before what is known as the blizzard of 78. Tom, we're going to have to research that. There weren't a lot of maps available then to really do a great comparison. But that's something we can certainly entertain. And in fact, as we go into next year, we're coming up on a big anniversary, the 45th anniversary of both storms. So I think what we will do is probably table that, and because we're going to need to do a little bit of research on that storm. But that was actually a big snowstorm and set a lot of records until the actual blizzard of 78 2 weeks later broke the records. So I will get, Tom, that is something I will take a note on, and certainly we will take a look at that. So let's see, from Ethan, is it safe to assume that places in between the climate sites, like Worcester and Boston, for example, saw blizzard conditions as well, or are they more on a localized side? In this case, Ethan, no, I think that's a pretty safe assumption. We use the airport sites just because those are calibrated sites and we know their reliability. Not to say other weather stations aren't, but these are kind of the backbone of our network. So yeah, we know, for example, blizzard conditions were over much more of the area than just at these locations. So we kind of look at, Boston to Worcester to Beverly was one corridor for that. So yeah, you can certainly assume that places in between did have blizzard conditions as well. So let's see. Just going through a few more, and if we got a lot of questions, so if I don't get to yours, don't take it personally. You can shoot me an email, and I will certainly be happy to answer it for you. From Richard, has the criteria for blizzard conditions changed over the last 50 years? Yes. Actually, at one time it included temperature, and you noted that in your question. They took temperature out of it. It used to be, and I don't remember the exact temperature, but it had to do with Arctic air. So this would have been a case that met that temperature criteria. I believe it was 20 Fahrenheit or colder was the old criteria. Now it's simply the wind, gusts or sustained, 35 miles per hour or greater, the visibility, quarter mile or less, and duration, 3 consecutive hours, or the dominant. It used to actually have to be 3 consecutive hours period. Now it's a dominant condition over that 3-hour period. So there was a little bit of a tweak in there. And you should note too, these automated systems don't always show visibility below 1/4 mile. So we do use 1/4 mile or less, as opposed to truly less than 1/4 of a mile. So let's see, from Michael, when he checked the hourly observations, it seemed that most reporting stations showed winds from the due north rather than northeast. Did the storm track slightly farther east than originally forecast, or other factors come into play? Yeah, because the storm was a little more offshore, we had more northerly winds, and what that did was brought that Arctic air right on down into us and ensured that we stayed all snow. It also helped with the snow growth. But yeah, an offshore track is going to give us more of a northerly wind as opposed to a northeast wind, or even an east wind. We get an east wind when the storm is kind of hugging the south coast, and that can bring in trouble with bringing milder air in and causing a change to rain. So that's a good observation. Let's see, going on, from Ronald, could this blizzard have been as bad as the 78 blizzard if the storm slowed down and stalled? Yeah, certainly. This, luckily, it was a pretty progressive storm. You know, it did its thing and gave us a good shot of snow. But yeah, if it had stalled, we could have been, I mean, we had, what, a 31-inch total. We could have been looking at totals well over 3 feet if this thing really slowed down and kept the snow going over us for some time. But fortunately, things were pretty progressive, as we call it, in the atmosphere, and it didn't slow down. Unless you really wanted to see that much snow, Ron, then there you go. Let's see. Just moving on. And again, there's just a lot of questions. I don't want to keep everybody too long. Let's see. So from Chris, this is a spotter question. This is a good one. So it's hard to judge blizzard conditions as a spotter, mainly due to the wind factor. And, you know, being in the suburbs or a populated area, you most never see the wind. I agree with that. So what do you want to hear from spotters calling in their gut, telling them this is a blizzard? What you can just tell us what you observe. If you are seeing near whiteout conditions or whiteout conditions, let us know. When I was watching the storm, definitely you can tell the visibility was less than 1/4 mile. It was near zero at times when the wind was kicking up. If you've got an estimate of the wind, hey, all the better. Just tell us what you observe, and then we can ask you questions or take it from there. But any information to me is good information. So don't hesitate to say, you don't have to be the one determining a blizzard. Just say, look, hey, it's snowing really hard. I've got, the visibility is near zero. I can only see a few hundred feet. The winds are gusting. I'd say they're pretty strong. Hey, that's fine. We can do a little more digging of some of the weather information to kind of supplement your report. But whatever you want to tell us, that's certainly great. From Anne, talking about the storm tide and wave height table, was that built based on the erosion you were talking about? No, well, that was built on experience with past events. So we took events from the 1990s and 2000s and 2010, really. We look at different events when they occur. We look at the water level and the offshore wave height, see what the impacts were, and then we kind of just determine the table impacts that way. So kind of working backwards, but it's more based upon experience with past storms. The erosion is something that we found out more from Coastal Zone Management, and they're one of our partners that kind of are eyes in the field telling us what's happening and if we need to ramp up messaging for that. So good question. Carrie just had a question. The surprise there was no thunder snow. Why was there no thunder snow? Well, we didn't have the instability. We had a lot of strong lift, but just didn't have the instability. There was, I believe, some lightning offshore closer to the low center, but nothing that made it close to the coast. I guess, unfortunately, Carrie. Sorry. We'll try next time. From Ethan, in terms of surface observations, our CWOP site, those are the Citizens Weather Observing Program sites, generally reliable, and do we use them for any official observations or products? We do. With personal weather stations, we don't always know the sighting. We don't always know the sampling. So wind gusts can be sampled at different times, 1 minute, 3 minute, instantaneous, and that affects the strength of the gusts. But we incorporate them into our storm summaries. We do a quality control kind of in-house. Does the observation make sense? Does it fit with other observations? They're also used for the models, to verify things like the national blend that I showed. There's verification that's done on that. So a lot of these other weather sites are used too. So if you have a weather station and it transmits data, chances are A, we're looking at it, and B, it's being used in the modeling community. So there you go. Excuse me. Another question from Kevin, different Kevin, has a questions first on the NBM. Is there a website that came from, or were those in-house graphics? The ones I showed are in-house. They are working on a public site for the National Blend of Models. If you do a quick online search, National Blend of Models or NBM, it will come up with the site. They are working on adding some maps to that, so you should see that in the next few months going forward here. So that more to come on that, but you will be able to have access to the NBM data. And his second question, he said this was an incredibly dynamic system. Curious about what features about the system the staff in the office was talking about in the few days after. Really just talking about how quick it deepened how strong it was. Given the pattern, the upper air pattern was moving right along, and often we don't see, things like this. Remember the 500 lower show closing off. You normally don't see that with this type of setup. Usually just moves right along and you're done. But we like to see a big high pressure block kind of over the Maritimes or over Canada. Didn't have that, but it was able to still strengthen. A lot of it had to do with a lot of the energy it had coming out of the Gulf. Think a lot of heat and moisture, thunderstorms offshore. That really helped the system strengthen rapidly as it moved up over us. And kudos again, the European UK Met models did a great job. The NAM did a very good job too in showing this potential. That's kind of I'd say that's what we're talking about, Kevin. Just how much this storm was able to really produce in the form of snowfall and even coastal flooding, having the winds and seas ramp up so quickly in almost less than a 12-hour period. That's pretty impressive storm. So there you go. Good question. Question from MJ. In this particular storm, did ocean effect snow add to the totals, or were the snow totals from the main storm? The map I showed was from the main storm. There was some ocean effect afterwards. So yeah, we didn't include the final totals, but there was some ocean effect behind this as well due to the Arctic air and the northerly flow. From my friend Kevin Lemanowitz, hey, good to see you with us, Kevin. Yeah, this is another concern. So Logan showed 0.45 liquid and 23.6 inches of snow, made a 52-to-1 ratio. Rather ridiculous. Yes, so let me explain what's happening with that. These automated gauges, they're not the best at being able to melt snow and produce an accurate liquid amount. So what happens, what you see in our climate summaries, it's all preliminary. What we have are other observers, in particular the CocoRoz network, where the measurements are done manually. The snow is melted down and it's more accurate. So what we do after the fact, now remember, everything you see from our office with these climate sites is preliminary. Even the things you see listed in the public information statements, the snow totals, all preliminary. What happens is this data, in particular the observations, let's say from Logan or TF Green or Worcester or Bradley, they all go down to the National Centers for Environmental Information, known as NCEI. It used to be known as NCDC, the Climatic Data Center. So what happens is when we have an event like this afterwards, we go through, we obviously know it's wrong. We go through and we open what's called a ticket, a trouble ticket, and we can go ahead and put in what we believe was the actual melted precipitation amount. So we submit that to the NCEI, they review it. If they approve it, which they typically do, then that data gets corrected for the official record. So rest assured, this will go down. Yeah, it shows up as looking kind of funky, preliminary data from our office in those climate summaries, but once it's certified, it takes, it's not instantaneous. It's usually a couple of months afterwards by the time this all takes place. The certified data will be more correct that goes into the records. So what I recommend is if you see, a funky reading like this, and you're almost always going to see it in snow, these gauges were not designed to melt snow very well, unfortunately. Go take a look at the CocoRoz network, cocoroz.org. There's a bunch of nearby observations around Logan and some of the other airports where you can actually get a better idea of the snow to liquid ratio. And just on top of that, these ASOS units in particular, when they were installed, remember, they were designed for airport operations. Unfortunately, many of them are owned by the FAA, and their main purpose is to help with airport operations. Get the flights in and out, runway selection, things like that. So climate is kind of taken a backseat, unfortunately. So we've had to deal with that since the mid-1990s when these were installed. But it is something that we do behind the scenes after the fact, before the data is actually certified. So Kevin, thank you for bringing that up. That was a great point. Okay, so with that, I'm going to leave it there. There's also, John had a follow-up question. Why did Boston stop recording snow depth? That's exactly why. There are contract observers there who help us with snowfall and things like that, but part of the deal with the FAA is they don't measure snow on the ground. So unfortunately, we just don't have it. We have it at Providence and Bradley, but we don't have it at Boston anymore. So, all right. With that, I'm going to go on. Let's go on to the weather briefing, and you're welcome to stay. And again, thank you everybody for joining us tonight. We had a great turnout for this, a lot of great questions, and I appreciate your participation as always.